Good morning, everybody. Good morning, good afternoon, good evening. Welcome on into the Dragon's Den. How are you doing today? And projects. We've had a few extra streams in the last couple of weeks, and we'll probably have some more as we move forward up until Rocky Mountain. Jump up here and stream a little bit, but also just the crunch of getting ready for the printer uh, or not dining room table right now, printing some maker coins and stuff for the. Welcome on in. Everybody's doing well. So this week we've been working on the enraged rabbit carrot feeder. We've got most of that built. Be going on the 350 Pride Hero. And Saturdays now we're working on our black box build. Today is going to be the second uh, guide. Trying to do one stream per guide because that will help us go through and have very easy, like, hey, future builders, I'm getting ready to work on this piece. I go and pull up this. Now on Twitch, because I'm just affiliate, not partner rated, things age off fairly quickly on Twitch. So I am cross pollinating these videos over onto YouTube. It's just a straight export out of Twitch over to YouTube. So go over and check out the channel on YouTube once again, Dragon 72. Excuse me. And you will have all of these videos there for. With that, let's go ahead and get started into the build today. Here to our browser window. And we've got in each guide, we have, it'll highlight what parts you're going to use, both printed parts, physical parts you will use. So that will help you kind of find what you need for that particular day, especially here when you're dealing with your pulleys. A lot of your pulleys are in your KB 3D motion kit, which would be in the big square box that has duet stuff. It also has linear rails and stuff in it. So you might have to grab a few things out of different. We'll be using our pulleys out of the Blackbox motion kit. All the pulleys. I did grab the linear shafts and here as well because I know we'll be needing those. We've also got one of the rails. We've got our, I think it's a size 8 linear rod, and of course our hardware pack. So it always helps to try and figure out what it is you need, get that stuff set out for the. What is it exactly? This is the Blackbox Mini Edition build by KB3D. Let me grab this. So this is the Blackbox wiki page that I just put up. And there will also be a configuration page over on KB3D. Get put up here in a second. Bear with me 1 second and I'll grab that up piece for you. So the Blackbox 3D XYZ, that is the wiki for the tool changer build that we'll be working on. And then the next link that I put in there is the link to the configurator page out on KB3D's website. That's where you can go. They have all kinds of subkits and everything. But the link I put in there for the actual configurator page has my affiliate code at the back end of it. The question mark AFFP equals 3151. That's my affiliate link. It just gets me acknowledgement and it helps KB3D track orders that are being placed from the videos um, to help us see these videos help the uptake. Yes, this is a whole printer. Yes, and I saw that you were working on the tap changer. I know that there are some issues with the tap changer and that they're making some more changes to it because Zombie Hedgehog was doing that build as well. Um, but I was looking into that and thinking about it, but this was something I've been working on with KB3D on since Earth last year. So this kit made it into production finally, and this is one of the kits out of the first batch. So I will be doing these build streams to try and get this out there. But this is a 5-head tool changer. I'll say similar to a Prusa XL or the old E3D tool changer. So it is the actual tool changer. The nice thing on this printer is it's water cooled. So there is a strip of aluminum at the back where all the tools mount. So you can keep your tools hot and ready. And you've got the water cooling while they're sitting there in their cradles. Then on the X gantry, when you pick up the tool, also aluminum to aluminum with water cooled block on the X gantry. And that will keep your front end cool. So I don't know the personal issues. I know Zombie was having some issues. I believe it's in the actual tool pickup mechanism and getting the proper consistency. There's still a little bit of wiggle and jiggle there. It's not as rigid as it could be. So I believe, but Zombie Hedgehog will have more on the things that he encountered. And that's why he stopped at just 2 tools and didn't build out his, because he knows that there are some other changes. Um, But yeah, I would like to build a tap changer down the road. I've got quite a few other projects. So project wise here on the channel. Um, so project wise here on the channel, we're working on the black box build right now. We've been working on the 350 Trident kit from DFH. We're doing the Enraged Rabbit carrot feeder build for that right now. We've got a couple of droid builds going on right now for the DO and a mini chopper droid build that we'll be bringing to Earth Creative Sprint this year. We've got a Milo mini mill inbound. We're going to reprint and rebuild the trad rack because the trad rack I have back here behind me was built during the closed beta and they've modified some of the files. So we're going to reprint the files and basically tear it down and rebuild it to go on the K3 behind. Also, I need to make the extrusion a little bit longer, just a few millimeters longer, because the extrusions that I bought originally won't fit um, the bolt pattern for the side of the annex. I need to get a little bit longer extrusion. And then we'll have a MMU3 for the Prusa Mark IV that's sitting right here. So we'll be building that. So this is really the year of multi-material here on the channel. So we're doing 2 ERCFAs, one on stream and one I'll probably just build, or I might do just stream straight to YouTube for that. Brad rack, the Prusa MMU3 to go on the Mark IV, and then the BlackBox Tool. After that, we may consider a tap change other board. So these are the. I was also looking at the changer, but I don't think that's fully set to go. I am not in Ohio. I am in North Carolina, and KB3D is. Hey, Nick, welcome on in. Flip back over here. By the way, I love my coffee here on stream. You'll see various things. I do have some coffee cups of my own, but grab this from Pete Savis. This is I am a maker cup. Proceeds from this get sent over to the Sanjay Mortimer Foundation. So any of the what would normally be the profit from buying one of these gets sent over to the Sanjay Mortimer Foundation. Okay, cool. Projects and data. Yeah, so KB3D sponsors me in this channel. So that's why, I spend way too much is. But yeah, Chris and Chris, they do sponsor the channel here. So we've done a few builds for them, from them, and so forth. So we're gonna get started on the build now. But yeah, North Carolina's been pretty nice. We just had a major rainstorm. Well, not a major, but a pretty heavy rainstorm last. There's a special mailing route from KB3D to yeah. USPS and UPS know this house very well, and yeah, I'm surprised I don't have a direct line. I should just have like I'd say a direct line of credit, but I think what I need to do is just set up an allotment from my paycheck directly to KB3D. So I just, it's just ready to go. Package away keeps the doctor away. Pretty much. Doesn't make the wife happy, but keeps the doctor away. So we've got a preparation section here that just basically talks about, hey, be careful with your bearings. If you don't pound your bearings in with a hammer or anything. Use a press. A pair of Nipix flat jaw pliers works really well. Thanks for KB3D for sending me a set for Christmas. I've used them on every single build since I've got them. And that's just to protect the bearings and keep flat spots. If your linear shafts are a little tight on the bearings, use a little bit of sandpaper, some fine grit sandpaper to get those cleaned down some, get any burrs off so that they go in. You don't want to make them too, they shouldn't just be able to slide in and out real easy, but you don't want them to be like real. Um, for all the tool prints that we'll be using today, this isn't all of them, but print these in a cheaper filament. So this is standard PLA. So print all your tools out in standard PLA, where all of our printed parts that are going on the printer, these are Priline polycarbonate carbon fiber prints. And these all printed out very well. This is the top. So this is the top surface on these prints, bottom surface. These came out very, very well. At first, you may look at this and go, hey, your hole's not completely round. The top parts of these holes are not round. They are designed with flat in them. And we will be taking a reamer and making sure that these are perfectly round before they install. You'll also see that there are some heat sets already in here. That's because, like this part in particular, takes M3 on one side, M4 on the other. So what I did was I went through, and this is the only part that's getting M3s today. And since I had the M3 in the heat press from the ERCFA build, went ahead and did the M3s last night so that this is nice and cooled, so I can do a quick swap out for the first today. Yeah, and we have a note in here. Use both M3 and M4 let your iron cool down completely before you try and unscrew. No need to burn yourself. With that, oh, and it also does talk about for printed parts, all the installation tools may be used. If there is resistance in the hole, use the reamer until the hole is free and clear. So, like I said, any of the holes that need to have a part go through it, like these, we will be using a reamer to make sure that those holes are nice, cleaned out, good to go. So the pulley reduction house is this piece right here. Um, Gets M4 inserts at the top, and then it will tell you M3 inserts on each side. So the M3s have already been put in. We're going to go ahead and swap out our tip. We are using a set of CNC kitchen tips for our TS100 or 101 pine sole or any of your other pencil based um, soldering irons. At some point I have to heat this one up and just hit it with a brass brush to get. All right, so we'll put that away. Load this up. Now we're using the stealth press here. This is the Iconic Fab stealth press that we put together on the channel not too long ago. So we use this. This has been a pretty good tool to get our um, any of our heat inserts in. I just keep the actual power supply up here because I've got one that I keep in the stealth press and then another one that I keep over just for soldering use. That way I don't have to deal with burnt tips and all that good stuff. We're constantly swapping tips. Warm up. Okay, and what you just saw me do there is they look like they were pretty close to being flush. I just hit them right up against the edge of my metal workbench. That's going to ensure that one, I am flush, and then two, uh, metal to metal, it'll help pull out some of the heat out of these. Now, normally I would say scroll through here and do all of your heat sets in one shot. I rolled through the instructions last night, and I won't need to do heat certs till a lot later in the stream today. So rather than desk scrolling and then scrolling back, I'm just going to go ahead and turn this off, put it down out of the way, and we'll come back for those other heat sets and the parts. Um, so we have this part pretty much ready to go. We do need to make sure that we ream out these sizes here. I believe this is going to take the M8. 510 4 bearings, and then not an 8. Seems like it. That break coming up. Yep, that looks like it's going to be the 8. Taking an M5 through there. Use an M5 to clean that up. Once again, definitely look through, take your time, make sure you're using the right tool at the right spot. You're going to need to insert the flange yeah, flange 510-4 bearing. And we've got the shaft kit, so all of our shafts should be in here. And the rest of our bearings are going to be all through this box. Pulley will have our bearings. Units. Everything in here is labeled, so be good to go there. Use magnet. Not the bearing here, but I guess this is just all the pulleys. Nope, that was it. 510-4 flange. Like there's one on each end. So it talks about the left face of the printed part, so just make sure that we're looking at it the right way. Bearing should put down in there. Once again, use your, there's two things you can do. One, you can clean out the gap, and then two, like I said, use a press, whether that's a pressed bearing or either a bearing press or a pair of Dippics. These are flat-faced pliers so that you don't mar up the surface. And I'm going to now the other thing with reamers that I really like is they have a chamfered edge to them, which means when you use them, one, you're going to get a perfectly round hole, and then two, you're not going to bite in and go through a part. So on something like this where there's a step in it, you can get the larger one cleared out without impacting anything else and without digging into part. So just 2 turns with fingers, this goes in and pretty much snaps in. And then I'll use my pliers to finish it off. Once again, crossing the whole bearing right at the center so that when I press it in, the whole thing goes nice. what we're looking to do. Okay. So this is, they're saying the left face. We're going to locate the GT2 77 tooth pulley. Looks like this one, though they're not actually marked. And you will see me use a paper towel. So we have a hard surface here. Using a paper towel, if you're dropping things like rub screws, you'll see that they land and they don't bounce much normally. So that way you can dump things out and they'll stay right here without running all over the place and getting down into a gap or something. So as with any grub screw, we are going to apply our Loctite. We're going to get our Loctite on our set screws and get them ready to go. Hey, Steve Builds, welcome in. How are you doing today, my friend? I will say a lot of the things that I do on my stream are tips and tricks that I've learned by watching Steve Builds. So definitely watch Steve Builds and keep an eye out for his stream as well. Now, Steve, you have shipping for your black box yet? Just getting up and moving around. Yeah, he's over on the West Coast. So definitely keep an eye out. So we've got a GT2 77 tooth pulley. We've gone ahead and got our set screws started, and we're going to use a 9mm by 154 belt. And you've got your little closed loop belts in a separate package, so make sure you grab the 154, not the 188. Make sure you're grabbing the right one when you need it. And of course, when we're talking about our pulleys, make sure you also grab the right one because that's the 8mm, not the 5mm. We need the 5mm. And sorry, these are 40 tooth pulleys, 72 tooth belt. We'll get to those a little bit later anyway. Not yet, but you're sure it's close? All right, cool. So right now, my plan is one stream for each section of the manual. We'll see how that continues as we get further in. I believe there's 13 total sections of the manual, but that includes like the enclosure and stuff like that. So we should be up and running before we put the enclosure on. Okay, so this will go around 40 tooth pulley here. Place 42 pulley in the printed part with the hub facing the left. Hub facing left perspective of the picture. Pulley can only fit into the part one way, yeah. Press in an M5 by 70 millimeter linear shaft. Grab our M5 by 70s. T minus 2.5 hours for the C stream. Yep. So once again, we want to make sure that this goes in easily, which it does. That's very nice. And will it go through our bearing? Yes, it slips through our bearing with no issues. That's good. Now make sure you keep your belt on here. Last thing you want to do is put this all together and go, I didn't put the belt on. So once again, our pulley is only going to go in one spot. We're going to get that lined up, shaft through the bearing, shaft through the pulley, and we're going to push it through until it just starts to protrude out some. We're going to locate the GT2 94 tooth 188 belt, which is our other belt here, and one of the 16 tooth pulleys with a 5 millimeter. These. Once again, we'll be careful with these because we've got tiny grub screws that are real easy to lose. So Steve, what is on the stream today? Is this the secure build? How close are you to being done with that one? Damn, Milo build. I never remember your schedule. Yep, the 240Z inspired RC car. There you go. Yep. Sweet. Yeah, I've been trying to watch those, but I have to watch them like uh everyone. Like I haven't watched the full stream end to end yet, but we'll get there. We'll get there. Insert a flange bearing into the pocket on the right face, and insert the pulley and heart into the pram part with the hub facing the hub of the 42. Then you press the shaft all the way through the part. So the belt goes towards the hub. So in essence, they're in the same orientation as what they'll go into. Now we need to press our other bearing in on this side, which probably would have been better instruction wise to tell us to press both bearings in first. Therefore, we wouldn't have had anything else in the way or any chance of dropping parts out. But that will be a comment for Chris. Oops. Line this up in the correct orientation. Push our shaft all the way through. Up. Shaft is not lining up. It's kind of at an angle. The There we go. Now the shaft will line up. It was catching on the grub screw on big pulley here. Pushed up and wedged to get. Just moving that out of the way allowed the shaft to line up properly. Be able to pull out our shaft, push through, and 2 belts basically. Now we're looking at the looking at these 2 pieces here. What they're asking us to look at, locate the 2 reduction parts. Those here. Notice one of the face of these printed parts has a recess. Install one of these parts on the right side of the pulley reduction assembly with the recess facing the here with 2 M3x8 socket head cap screws. Feed it with on the other side. So once again, we're going to take a look. It should have a recess. Very slight recess. In my case, it's on the printed top side of the part. Tiny, tiny recess. And the screws are offset, so it will only orientate on one direction. To get that lined up, and we're going to use M3x8 screws. Here comes the fun part of trying to get this lifted up. There we go. So on the fastener kit here, it's 2 levels in the kit. And so you've got the top level on the right, the bottom level over here on the left. So just go through, find which screws you need. We need the M3x8 socket head screws. Go through and find where those are. So second one from the right at the bottom. That's where we'll need to go to grab our screws. Yep. I tend to get them both started before I tighten them down. Yeah, you don't know if you'll be started before remurf. Yeah, just so much going on this month between now and remurf. So I knew this was not going to be built by remurf. And my plan for remurf was bringing um, the salad fork and the um, micron. Micron's dialed in printing. The salad fork is giving me hassles for whatever reason. I think I just need to get the first layer fixed again because I was printing ABS with it the last time, and I just need to. I'm trying to print some PLA for right now. I just need to go back in and dial in my first layer height. There's those two end caps added, two screws. So next up is rotate the assembly. So it's sitting like this. And we'll have the 40 tooth installation tool, this piece, between the flat face of the 40 tooth pulley and the printed surface. It's going to go in here, push the pulley back against it. Rear side of the assembly, secure the 40 tooth pulleys. Now, once we have this, we're going to flip it over to this side so we can see it. And we're going to secure down our pulley. Now, there is no flat on the shaft here. So we're just going to be tightening these right up against uh, the shaft. So there is no flat to align with. One, and two. Now we're going to take our other printed tool part, other little tiny fork piece, and stick it in here. And this is going to be the gap between the two pulleys. So once again, we've got the tool in there. We'll have to rotate the pulley so that we can get to our scrub screws. There are plastic pieces in there. Pull the pulley tight against the plastic. Same thing. Holding everything tight with those printed parts. Going to set the screws on this on these pulleys. Rotate it around to get to the second set screw. Then we can pull our plastic pieces, and now our pulleys are set in the appropriate location for the next step. With the printed reduction tools, place the printed pulley reduction part top of the reduction assembly and secure with some M4x20 screws. Now the nice thing is this is where the heat sets are, so it's really easy to figure out which way this goes. Let's grab those parts out. in our pulley reduction piece. Make sure we get it oriented in the right place. These are going to be M4 screws, so let's make sure that our printed part is nice and clear. And that's done. Everything's nicely sized. M4 by 20. Pocket head cap screw. Now the nice thing is these are pretty much in order from by size and type. So that makes life a little bit easier when you're working on these or trying to find your screws. So M4 by 20s. Hey, Chris, how's it going? Zombie, welcome on in. Welcome on in. The zombie, we were having a discussion earlier with oh, what's his name? Project in Dad's Garage. And you tell him some of the issues you were having with the tap changer. Yeah, the biggest, blackest box. That is correct, Outdoors Danger Den. That's exactly what we're building. Uh, we're going to need one of our motors. And luckily, our NEMA 17s are all the same size, so you don't have to like go through and try and figure out which one's which. But we have the big motors for the Z and the A and the B, and then the tool changer or the locking um, motor for the tool changer is a NEMA 8, and the extruder is a NEMA 14. So there's a ton of mods already. Yeah, and people were asking me when I was doing the IRCFA build, everybody's like, "Are you doing this mod? Are you doing that mod?" No, no, I'm not. I'm building it the way that it goes, or the vanilla way, and then I will look at mods. I want to make sure I get it working first before I start adding a bunch of mods to it. We've got our motor. We're going to install a GT2 16-tooth pulley. Making sure what all I got in here. The one thing, Chris, is on the pulleys, there's no like size designation on them, and I know that there are two different size and styles in here. So I hope I just put the right one on there. They're gonna make me double check. Okay, so that is a 16. Well, all of these the same size? They didn't look like it. 16 and 20 in here? 16, 16 tooth top flange is much deeper. Top flange is much. Okay, so are you saying this would be the 16 and this would be the 20? So this is a 16 with the bigger, thicker flange than this one, which would be the 20. Opposite. So this is the 16, this is the 20. This is the 20 with the bigger, thicker. Okay. Okay. That I can do. There's too many sizes. So far we haven't used any of the 20s. It was a 16 in here and now a 16 in here. One of the set screws with the flat, cut them with medium strength thread locker. Okay, was there a printed installation tool for gap here? And if so, was it this little half moon shaped thing? It looks like, yeah. We'll get our thread locker ready on this. The downside of when you print out all your parts and your tools ahead of time, it's kind of like, which tool is which? Which is why I only printed like 3 sets. And I think what I'll be doing is printing the installation tools out before. Oh yeah, that does show the tool there. It just doesn't, you just don't realize it. I think the liquid um, thread locker would probably work out a little bit better on grub screws. Just because they're so fiddly and you get the least bit of, I'll say, tension or pull on them and they'll pull off of your, especially the smaller ones like. Okay. And the printed tool goes with the smaller jag up. Gonna go on there like that. Yeah. And our pulley goes, which thick base down. That screws down. And line up one of your set screws on the flat. Down together. first. Uh-oh, you didn't get one of those little saws? That sucks. Hey, Shenanigans, welcome on in. Welcome on in. So we've got that set up. Remove the parent installation tool, orient the motor as shown with the connection for wiring harness facing you. Okay, so wiring harness connection facing me. Mount, got the one offset jag here. That will also be facing me. And then we'll need some M3 by 10 screws. And wires facing me, and a little extra jag out on the printed part faces me. Getting these aligned and screwed on. I need to go down to Harbor Freight. I haven't been there in a little while. They keep sending me the "We've missed you. Here's a 25% off coupons." I guess I need to go and buy something. All right. The Z motor's connected. Motor assembly aside, turn your assembled frame upside down. So now we need to get our frame up here. Let me get a couple of things out of the way here so that we can get our frame up here. And I am trying to move some things out of the way because that frame is chunky. Definitely need to get things out of our way. And our frame. Those of you that weren't here for the first one, is our frame. And it is primarily 40/40 extrusion with some 20/60 as these lower cross braces. Everything here is 40/40, 20/60, 20/20 for the rear rail. And yes, chunky boy. Oh yeah, Shenanigans. The Harbor Freight stuff has worked out really, really well for me as well. We're gonna set turn the assembled frame upside down and orient the front towards you. Insert two M4 by 6 or M4 slot 6 roll-in nuts into the center slot of the left, right in the perspective of the. So we're going to take this and flip this over. This is the right, this is the left. Okay, this is just the rear rail that I'm seeing. We are going center slot. Okay. So Chris, how many of the M4 series or slot 6 roll-in nuts were actually M5s? And yeah, it looks like the holes are opposite ends, and these are slight. These aren't going to work. Need the M4 smaller ones because this is my 2060. Those are slot 8 are the bigger ones. Being all formal and using slot 6, slot 8, and we're used to 2020 and 4040. Tells me to put 2 here. It's going to tell me to put 2 on the other side. Now we're going to place the EF10 bearing on top of the left 2020 or 2060 extrusion. Line up the holes in the M4 slot 6 nuts. Mount it. So the EF10 and the EF8, I think it's EF8. Anyhow, those two bearings, these are these two bearing blocks. Yeah, like 50%. Jeez. And yeah, just to confirm, Chris, we're putting the smaller of the two blocks in on this step. So we've got two different block sizes here. Oh, they are labeled on, oh yeah, they are labeled on the block. Look at that. Look at that. I didn't notice that, which I couldn't tell because of the coloring of the bags, but yes. There's our EK8 and the EF. This is the one we're going to use is the EF10. We're going to use M4 by 35 socket head screws. So this comes with a locking. This is supposed to be That was good. Throw an M4 fender washer. That would make sense. I was like, wow, that just went straight through. M4 fender washer. Keep reading all the way through the instructions. So here we're talking about the EF10 bearing. Here we're talking about placing the EF10 bearing. And then repeat for the other EK8 mounting hole with another. So there's a typo right there in this section. Okay. Okay, and this is calling for M4 by 35, and I just bottomed out, and I'm not even close to being tight. Yeah, so these should be probably E430s. I'm gonna have to grab my notebook to take some notes here. Did I miss a printed spacer? That's the EF10 liner. Piece. Right, EF10. Oh, that would make. Not that one either. Okay, which one's the EF10 liner then? These parts. Do they go up from the bottom or top? Going from the top? Okay. Yeah, it would be great if I looked at the live CAD, wouldn't it? Especially mention that we would probably need to look at the live CAD from time to time. And it'd probably help if I show that. What we're doing here is looking at the live CAD. This is that bearing block we're working on. Here are the liners, screws and fender washers. So these parts will wind up going like this. So liner, M4 with a fender washer on. Hey, good morning, Liz. How are you? And the location of this isn't important right now because it hasn't told us anything about the position. We're just getting this on there and we can move that around as needed. We haven't seen anything about the position. And that's where possibly having like an exploded view here versus this. So it shows the washer, the fender, the liner, and then the bearing would probably go well right there. Similar to, something like this where it kind of shows it a little bit better of how things are lining up and going in. And I know the manual was written ahead of time or by somebody else. No worries. Place the ribs of the Z-axis EF10 installation into the center slot between the bearing and the front 470 40/40 extrusion. Slide the EF10 bearing assembly and flush with the printed installation tool. That would be one of our installs. We've got the EF10 CE, so this is the tool we're going to use. Got the little slots in there, and we're flip. going from this side. I keep looking at this as a trident of this is the front and this is the back. This would be the front right side, front left side. Just plug it up. Tension. Need to remove printed EF10 installation tool and locate the Z-axis 80 tooth pulley. Another one of our pulleys. 80 tooth is our Big Daddy pulley. Get your set screws. Good morning, Retro TV Maker. How's it going? All right, Chris, thanks a lot. And these things screwing for behoove you to get them fairly well threaded down in there before you start putting it together. Otherwise, you're trying to hold pieces together while you're once again screwing for days. Um, Slide the number 8 by 520 linear shaft into the printed tool. So we're going to slide our shaft into our tool. Luckily, that's loose, but that's good. So if it's a very tight fit, you would be able to put a heat set insert in here and then use an M3 screw to basically wedge it back off. But that's a fairly loose fit. But since this is only being used to set a distance, we're fine with that. We're installing the GT 80 tooth pulley. So the flat side of the pulley is flush with the printed tool. Once again, make sure the tool's all the way up. Coat the set screws with thread locker and secure the pulley. And these are getting secured once again directly to a smooth rod, so there's no flat on this rod. And then this comes straight off. And that's where it says if it's too difficult to remove the printing tool, you can put a heat set in there and then use a long screw to basically press it off. Didn't need to do that. That was a preparatory step. Now we're going to put two more M4 slot 6 nuts over on the other side, once again in the center. We want leave the holes facing opposite directions again. So we're going to use our printed spacer to set the gap for our T-nuts. Looks good. Wrap the GT2 94 tooth 9mm 188mm loop belt from the pulley reduction assembly around the 80 tooth pulley mounted on the linear shaft. Okay, so we need our 188 belt. So our 188 belt is on our smaller pulley. We're going to take this and wrap it around the 82 pulley on our shaft. And almost. There we go. And we're going to let our gear reduction assembly dangle. Okay, so we've got our EK8 bearing. Talks about a bearing guide. That's this. Place the EK8 bearing with the linear rod assembly installed on top of the printed EK8 spacer. Be certain the EK8 bearing is oriented properly over the spacer. Locate the EK8 linear parts or liner parts and install one on each mounting hole of the EK8 bearing. That would be these guys. Clean off some fuzz real fast. So we're using these ones that have the multiple step downs to them because there's an extra step down inside here so that these are going to fit right in that hole and give us that upper spacer we had in the other ones. These will go down into the spacer. Okay, we're going to line these up. So we're going to take this through our rod. Get this lined up. Other rod and will come through the other bearing slide here. Maybe, maybe not. Will be good for the time being. We need our M4 by 45s. A couple more fender washers. Where we have whatever reason the one keeps rotating on me. It will stop it. Slide this down some. Rod lined up with the other bearing. Bearing in. And EKE-K8 printed part here. Do the same thing. Will allow us to get the thing lined up. Place the ribs of the EK8 tool into the center slot. All of a sudden everything lines up and it moves a lot easier. Pull this tight. Now we will secure down our tool. PK8 block. Now there will be a pulley reduction assembly brace. Let me go ahead and it didn't say anything about mounting this. And I just realized I've got the orientation of the block here backwards, so I will need to out this back off and turn it around. There we go. I don't remember it saying anything about mounting. See where this is. So the pulley reduction assembly brace. This is a 10 by 20 piece. Let me clean up from this. And once again, that is a 10 by 20 piece, 350 millimeters long. So this is what looks like just a one flange of a 2020 extrusion. Go ahead and set this down on the ground for the time being while we work with this piece here. Need some M4 T-nuts. One at one end, two at this end, and the two at this end are opposing directions on the outside edge. And we're going to need a 2020 corner bracket. There are different sizes in here, so make sure you get a 2020. Well, we did the frame on the last stream, so we're just working on the z-axis, and I'll show you that that linear rod was the only thing that we've added to the printer since the last stream. So we've got our 2020 corner piece. This is where it gets a little weird. So we're going to flip this on, and it has little clips on each side. Good clip on or clip in. And then we're also going to have some insert that go in as and not sure the full purpose, but I'm sure that it will be made made aware to me at some point. Up the steam on this. Place. And this goes down on this end. And we're going to use an M4 by 8 and an M4 washer. 4 by 8. Button head. M4 by 8 and a standard M4 washer, fender washer. How's it going, Pez Liz? Welcome in, welcome in. Hey, Retro, welcome in. All these people with bamboos. One of these days I may do a bamboo, but I'm going to line this up so that the bottom is flush. Go ahead and secure that. The other side, going here, other side. That wants me to go and do the pulley reduction, put that in place. So we'll put the printer back up on the table. And so this is our pulley system, our pulley reductions right here. We're going to need to put a M4 roll-in T-nut here. Let me rotate this around. We're going to need a T-nut. There we go. So it's telling us to put a T-nut right here so that we can secure our pulley reduction to the 2060. We're going to put a T-nut right here. Another one, our M4 roll-in T-nut. Hole facing this side is the aesthetic thing. Will be hidden. Slide that over, and we're going to use an M4 by 14 socket head cap screw. And this is going to go through this bottom wing here and into that piece or into that screw or the T-nut. It says to loosely fasten it. Okay, I was like, what is it talking about? So we're going to take our M or our 10 by 20 and we're going to hold it this way until our T-nuts line up with these holes here. Be interesting. And what are we going to use? 1020 extrusion down. So now we need to put another M4 over here. That we will use to connect to the corner bracket. M4 by 22 socket heads. So these are going to be used to go through this piece down the pulley reduction and go into the T-nuts down in this piece. So those are up. Those are good. Flush down here, not flush here. Not flush at all. So this is an extremely tight fit. So something need to give a bit. This is an extremely tight fit. Down here at the bottom, we are going to completely tighten these M4 by 22s into that 1020 rail. Maybe so, Pezlas. So we've got these two completely flush with the end down here. And we're going to get this lined up and loosely secure it with a M4 by 8 button head cap screw. Flip this around. That was it. Okay, so we need to get an M4 by 8 button head screw there with an M4 washer. Then we'll be looking at making sure that we're nice and square to the frame. So moving this end sets the tension on this belt. And the thing I'm going to do is I'm going to take my 1, 2, 3 block, make sure that we are nice, good, and set it at a 90 degree up here. We should have a 90 degree corner here as well with our corner block. And we'll take some measurements. Don't mind me, I'm just going to put my head here so I can actually see what I'm measuring. 201. We're good. So we can lock down this side and this side. Everything is square. Everything is locked in now. Now we're going to place two more M4 nuts over on this side of the 2060, and this is where we're going to install our motor. Then one up at the top. We'll get these all aligned. We're going to guide the GT2 16-tooth pulley on the motor assembly. Orient the X-axis motor assembly is shown. Secure the 2060 4x10. Okay, so M4x10 from what is seen as the top, and then M4x12 from the sides here. Okay. What I'm going to do is just try and get my holes lined up here. I'll worry about this one later because I can slide it up on. Get our belt around it. We'll get the M4x12 going in this way. And we're not going to tighten those down yet because we'll need to slide this over. This is going to give us our belt pinch here. Completely missed the nut. So proper tension on the belt loop, completely secure all of the nuts. What is the proper tension? It's probably the same 3 mil deflection that we had before. Think about right. Everything's moving good. Belts are all lined up. So let me go ahead and turn this around again and I will show you where we're at. So this, of course, is the bottom of the printer. We've got our Z motor connected into the first reduction gear pulley. So this is a 40 tooth pulley. Goes to another 16 tooth pulley that drives the 80 tooth gear. So as you can see, moving nice and easy. Our rod is lined up. We've got our support bracket in place. So everything's good so far. And once again, all of this is at the bottom side of the printer. Z-axis bolt belt pulleys. Locate a GT2 40 tooth pulley with an 8 millimeter bore, and we had those. So 40 tooth with an 8 millimeter bore. I need both of them. I know we will need. So we're going to set one of these on here with the collar facing our EF10. We'll have these pulley tools that we printed. They just look like little knobs. Put that on the rod as well, and that'll only go in a certain amount. We're going to screw these down. Install the set screws on here, making sure to pull this in tight and then the pulley in tight to the printed piece. That side done. And I believe we're going to do the same thing on the other side. Remove the installation tool and do it on the other side. same exact thing are the collar of the pulley goes in first. Put in my set screws. With some Loctite, of course. That on. Take our printed part, put it at the end, pull the pulley back so it's lined up with the printed part. One down, spin it around, tighten the other one. There we go. Now we've got our drive system, and then these are going to drive the pulleys, and this is each side of the bed. Now we need to start putting in our Z-axis idlers. I'm going to take this once again and pull it off. Um, I like having the printed tools. It really helps. The yeah, I like the printed tools, especially things like this. It's a lot easier to use these to set a distance based on the extrusion, and having each one of them labeled with the type really helps. Now, when I printed it off, it said to like print two of these. You only really need one. There was a couple of other places where it said to print like X number of these, and you really only needed like two or three. There was a lot of extras. Now, this had I guess a locking collar, and the pen had the locking clip. We are not using these, right? Because I didn't see anywhere where it said to use these. Okay, Royal Nami, go watch Dune 2. Okay, good. That's what I was thinking. So I can just toss those. I wanted to watch Dune 2 as well. I plan on doing it this weekend, but I wanted to watch Dune 1 to kind of refresh before going to Dune 2. And it wouldn't let me play Dune 1 last night. I don't know if too many people were trying to do it or what. Um, Now here, build the right side idler with diagrams, and then you'll build the left side, which is the mirror. So these are these two blocks here, okay? And we're gonna look and see. Wasn't a bearing, that was a printed piece. This is the one that's being shown. So we do this one and this one, we'll do them side by side so that we do them both at the same time. Now, we start off with being told to tap these bottom two holes here with M3 threads until we get to these M5 holes underneath here. Now, that being said, I do have taps. They're just out in the garage. So let me, I will put it on the be right back screen, and I will be right back. I just need to run downstairs to the garage to grab my tap kit. So I will be right back, folks. Okay, I am back. And yes, Harbor Freight Special, Pittsburgh, tap and die set. Um, Now, as I was running down to get this, I did remember I also have a set of combination drill and tap bit set. So you can use these to drill and tap at the same time with the drill. Um, I don't know if that is advisable on plastic. So my plan was to just hand tap the plastic parts. Right, I can find my what are these? 3 by 5. Give me M3 by zero point 0. Now I will say that I have used this quite a lot, and it is starting to get, I'll say, a little long in the tooth. But should work fine for doing plastic. Now, once again, we're tapping until we get to the M5 holes. So one will be shallower and the other will be a little bit deeper. I try and stay in the center and keep it straight up and down until I get a couple threads in. So what is everybody's take on tapping threads in printed parts? No CNC Kitchen did a thing on it, I believe, recently on the strength of tapped versus heat set inserts versus a few other things. Into whether or not, how much strength you get and retain out of it. Old pens, never anything else. Now I'm looking through the top hole down through the bottom hole to see when my tap gets all the way through. And don't just stop when you get your first inkling of the tapped part or the tap itself. Keep going because the taper, the first couple of millimeters of this really isn't doing anything as far as tapping through. Say normally on your metal parts, aluminum, whatever, was it like half a turn, back a quarter, half a turn, back a quarter, something like that? You're just trying to make sure that the chip load isn't getting, that you're evacuating the chips out of the part. Otherwise, you could jam it up, and that's how you wind up breaking your tap, or in this case, breaking your printed part. Two and a half drill bit preps holes perfectly. Yeah. So far, everything's been printed nicely. Chris's way of saying, "Hey, don't break the part, Luke. Can't afford to print new parts. These aren't 2-minute printed part um, on the Annex Engineering K3." And I don't have a 2.5 millimeter reamer, but I do have a 2.5 millimeter drill. Once again, you just have to be very careful that you don't drill all the way through it, because these are not all the way through the printed part. Make it easier to tap now, because that did move a decent amount. Terminology wise, what's the difference between a screw and a bolt? The difference between a screw and a bolt is a screw will thread into something, and that is the holding power that you get, is the threads of the material. When you're a bolt is something that is using a clamping force, because it has a fastener on the other end. So we take our M3 screw, right? And if we're threading it right into plastic, we're good. But when we just took those M4 bolts and put them into T-nuts, then or M4 screws and put them into T-nuts through a part, that turned it into a compressive force, which makes it a bolt instead of a screw. Same fastener, just different purpose. Yeah, dirty jokes come to mind, exactly. By the way, that's something I just learned out too, or learned about as well. And you'll notice I am not using any cutting fluid on this because we're doing a plastic part. You don't want to be putting any cutting oil on these because it could interact with the plastic of the part. Now this is polycarbonate carbon fiber, so it should be pretty resistant to most stuff. Yeah, these are great for speed tapping. Like when I got um the Tensor 3D um B stock rails, they were uh already drilled to M5, which means you can't thread them for M5. You have to thread them for M6. And that's great for dealing with that. You have a 5.5 drill, drill them to 5.5, and then thread them with the M6 threads. If you don't have a 5.5 drill, just go ahead and drill them for M6 threads. Just go slow. Back them out when you need to clean out all the chips so you don't tear anything up. So we've got our two parts now tapped through to the 5mm hole. Now we need to put some heat set inserts into these parts here. So we'll bring our inserts back up, or our self press back up. And we've already got our M4 tip on it from doing the ones earlier. Let my coffee get cold. Make sure you get these nice and flush. Back down there. Now we're going to need our GT 20-tooth idler pulleys with 5mm bores. I'm going to assume all these are the same. We've got two. So the upper, or the one that's recessed to the back, needs to be put in first. Once up, we did. We change. We didn't change. Yeah, the one that goes in the back here gets put in first. And we're going to press in a M5 by 25 linear shaft through the hole. Okay, so we'll grab our M5 by 25s. Hey, Shaudell, how's it going? 430, 415, 50, 5, 35, 30. Hey, 525. Now, before I start to put these in, once again, I'm going to check and make sure that it goes into my pulleys freely. And that I can get them into my printed part. Because if I can't get them into my printed part right now, now's a good time to take your reamer. And these are M5s, so grab your M5 reamer. And they don't go all the way through, so you can do it by hand potentially. Right? Doesn't need a lot, and I would do all the way through. Now your pen should go in without any issues. We validated that it will get into the pulleys and now into the printed part. Do the other one as well. Okay. Now, once again, we're going to start with the one in the back. We'll take and line up our pulley in with the hole. And take one of our M5 by 25s. Press fit it in. There we go. And if everything's lined up, it should go all the way in. There's your pulley. We'll do the other one as well. Push down on the table to make sure it goes in nice and flush with the top. The rear pulley first. Use a hand vise or arbor press if it's too much to do by hand. Then we're going to repeat and do the other pulleys. Then grab two more of our pulleys. Make sure that your rods go in nice, and these are some really nice dowels. Get our second pulley lined up in the hole. Now it goes in from the top. Press it through. Get it close. Push down on the table. Make sure it goes in flush. Now we've got both pulleys. So same thing for this one. Going to take and line our pulley up. Hole. In goes our shaft. Push it on down through there. And press it home. There's our two pulleys. Hey, Createx Brit, how are you doing? Welcome on in. Clean my little shards up. There's those two pieces. So far, at least. They're mirror images of each other. Put an M3 by 6 set screw with thread locker. And install into the deeper M3 threaded hole. Tighten the set screw until secure. That's interesting. So we're using a set screw um, to create the locking mechanism so that those pins don't pull back out. But the interesting part is we're being told M3 by 6. We got a plethora of different set screws in here. Um, I'm not used to doing thread locker, especially not on set screws going into plastic. Family let you sleep in. Oh, nice. Nice. Okay. Oh, so don't do the thread locker on these. Just take the set screws right in. 4 of those. Yeah. It wouldn't be bad if you were doing, well, it definitely wouldn't be bad if it was a metal part that you were, if this is a machine metal part. And I use um, polycarbonate, so it shouldn't be that bad. But if you've done your parts in ABS, that would be bad. So this is page 34. Okay, note taken. Um, Now these are once again uh, M- fairly long M3 set screws, and they're going into plastic. So you just want to be careful that you don't try and ugga dugga these down, or you will um, kill all those threads that you just put in there. So we are going to take this back and do the deepest one first. All right, so go until you feel the slight change in pressure. You probably don't want to go past that because if you do, then you're going to be um, stripping out your threads because once again, you don't have a lot of room and strength for ugga duggas. And this one sits proud if we're using M3 by 6. Okay, hold on a second. You only told me to do M3 by 6 into the deepest one, M3 by 5 into the other one. That would make sense. That would make sense. Let me finish reading all the notes and follow the instructions that it tells me to. Hey, Hobby Maine, how's it going? Put the sixes away and grab the fives. Wah, 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 wah. M3 by 6s for the deep ones and M3 by 5s for um, the ones up front here. And that's nice. So that gets in there with no intrusion, so that's good. We've got both in. Once again, these are just going into the um, M5 dowel pins just to keep them from coming back out. Need to make note of this one as well. Now we've got two of our tackle rollers, and we need some 494 bearing. Test tubes don't like to keep their labels. We're going to press a 494 bearing into our printed piece here. Hopefully press in easily. Nice flat surface, or your Nipix flat faced will work great. What you don't want to do is pound on these races, because as mentioned in the initial preparatory steps, if you pound on these races, you'll probably damage the bearings inside because you'll flatten out the races. Not the not the race, but the edges. Put a M4 by 10 socket head cap screw with thread locker. Put the M4 by 10 through the assembled D-axis tackle box roller into the heat set insert of the main printed part. So this is where we're going to run our thread locker on these and then go through a plastic piece through the bearing and then into the little shafts here. So what I'm going to do is actually see M4 by 10. I want to see how much shows through, because I'm going to probably just do it like this and then put a little bit of thread locker on it to try and keep it away from the plastic as much as possible. Go very small amount. Put your screw through, then put a little bit of your thread locker on. That way you don't get it on the threaded or the printed part at the top trying to stick it through the hole. We're going to take this, line it up with the M4 heat set insert, screw this down. You still want to make sure that it rotates, and if it doesn't rotate, back it off a little bit to make sure that your bearing rotates. So once again, if we were going through here and we had the bearing on either side, it would be fine. But because we're going through the plastic here, well, I'm going to stick my screw through first, then put a little bit, because if any of it gets on the bearing face, it's not going to interfere with the printed part. And once again, I am printing these out of polycarbonate, which is resistant to chemicals, but I'm not going to press my luck. Once again, we go until it's just snug. then we'll back it off just a tad bit until it can rotate freely. We don't want a lot of slack, but we don't want it to be compromised. Now we've got a couple of printed parts here. Lay these down. And our printed parts have little lips printed on them. And these are literally going to snap in place. They're going to snap in place in these holes, and you'll notice there's an offset cutout. And you want that cutout where the front facing bearing is. Okay? Well, it should snap in. I may have to very lightly lay on the edges of those. Okay. Well, actually, it goes on the other side. That would be why. It goes on the other side where we had the actually follow the guide where we can see our wheel is at the top. Snap in. Same thing on the other side with away from the holes. These sides had the little step downs in them. They're pretty tight snap fit. And move some things off here. We're going to need our printer back up here. Oh, and this is the back side here that it's showing. So let me turn this around. Easier for you, harder for me. Okay. Those things up. Okay, so here's the top of our rod. We're seeing the rear support bracket or the rear linear rail. We're going to put in our T-nuts right down here. And these are the slot 8s. So these are the bigger M4 ones that Chris sent us. Looks like one this way and one that way. All right, Chris. Well, we probably won't go too much longer unless I decide to go into another section of the manual. And I think we're almost done with this one. Place the right Z-axis belt idler assembly on the underside of the 420 extrusion and align the holes. Loosely attached with M4 by 35 through the Z-belt assembly and into the thing. So we need M4 by 35s. Probably means I'll need a set for the other side as well. So what I'm trying to do is make sure that I'm orientating things right. So I should see the two screw holes, and this should be over on the other side. So see the two screw holes. This is over on the right. I should see both of my pulleys. The one on the right or the bottom side of that picture is the one that's outmost. So we need to basically line up our screw holes. That part we clipped in is what sits down into the 4040 channel. I think we got these lined up. We'll start getting these turned in. Correct. So a screw is a screw when it's threaded in and the threads in shear are what's holding it. A bolt is through a part with a nut and a female threaded piece on the opposite end, and you're holding things together with compression. So that is loosely attached on those uh, M4s, and is loosely attached. Okay, then we're going to place one of the printed idler pulleys, installation rails there. I'm assuming that these are going to be the Z1 CE pulleys here, or pieces here. We're going to get that in the slot, push it all the way this way, and take our pulleys, push it over right up against it. Everything's pushed over nice and flush. You have a bit of a gap there. Okay. I'll tighten these down. Correct. Okay, so this is now in place. Now, rather than keep this in place and use the next one up here, right? I'm going to use this one because there could be slight printing differences between the two. So always use the same one if you have the option. So pop this out. That's the one we're going to use. We're going to flip the printer over onto its feet now. And we're going into this piece right here. So it tells me to flip it over and repeat. So once again, we're here. Where is this going? Right now. Oh, yeah. I'm confused because I'm confusing myself. We don't turn the printer upright. We flip it 180 degrees. Because these are lining up with these. So this needs to go down here. So, so once again, we'll get in our two M4 slot 8, aka 4040 peanuts. Line up our holes. Put it down in the slot. Get our M435 lined up. Now we're going to take the same printed part that we used before, slide it in here and push it all the way over. Slide this one over. Make sure it's nice and tight. And then tighten these down. And there we have it. That is the end of section 2 and the Z-axis motions. Now, Let me go ahead and take a look at section 3, which is the kinematic heated bed. Because I didn't look this far ahead. I just want to see like how intense this section gets. I'm just reading through this and seeing what kind of stuff we'll get into. Build our bed. All right, I'm just trying to see if I wanted to get into this section today or possibly call the stream early and um what do you guys think? Get into section 3 and keep pressing on. I will keep pressing on if everybody wants me to. I know we were trying to do one section per stream, but we can go ahead and get 2 in here. We can do another one of my marathon streams. Our corner brackets, we'll need 2020 or 2040 rails. Too long, too short. Let's keep going. All right, Pez. Too long, too short, and then we also need two more of the 2020s that are the same length. And that looks to be them. Oh, that leaves us not a lot left in the old box over there. Awesome. Okay, so leveling blocks and let me find the printed parts bag for this part of the build. That one. Got all the electric parts. Sorry, gang. We had um the axis. This is yeah, that would be this would be the right one. Okay. Take the tools that we've used and get these out of the way. Oh yeah. Thanks for the all right, cool Timor. Thanks for the lurk. How's it going, Hyman Robotics? So these would be those little printed corner bracket lock pieces that we had. And I got a little bit of stringing on these just because they were small fiddly prints with a lot of retractions. That and I probably could have used a dry cycle on the filament, but easy enough to knock those things off. And Need 8 20 corner brackets. K2? Well, of course it does. I built it and then you redid it with different colors. All the love that goes into it. These things are supposed to lock these pieces in, and these pieces have like little tabs on them, but they don't really lock in there all that well. I don't know if it was just a shrinkage issue or what. Getting the interlocking love. Later, hybrid. I don't know why these pieces do not seem to align and lock. The back pieces that are aligning, the other pieces fit in just fine. It's back pieces aren't aligning and locking in place. We'll just get these kind of set up and ready. I got 4 ready. Let me see how I get this thing started. Repeat these steps for the remaining 2020 corner brackets. Start with the long extrusion. Install an M4-6 roll-in nut as shown below. For 2 long ones, we're going to put a M4 2020 nut in at the top. It's 2020 corner bracket and secure it loosely with an M4 by 8. Pocket 4 by 8 button head cap screw. M4 by 8 button head cap screws over here. And through an M4 washers. Grab the M4 washers. Grab those as well. Hey, Mrs. Dragon, how are you doing? Welcome on in. Good morning. Good morning. Good morning. We made progress. We decided to actually go into section 3 and go past section 2 in the manual because we're that good and we're that far ahead. Take one of these, get one of these little backing pieces lined up in it, M3 by 8 or M4 by 8 through the hole, through the hole. So the printed little L bracket is basically what's providing the alignment nub between these. And I'll get it a little tight. I'm not going to go like super tight by any means. I'm just going to get it a little tight and put the washer there. That back off, put a washer on it. We're just making a little sandwich out of here. Through the washer, through the printed insert, then through this underlying piece, getting it lined up on the M4 nut. Just a couple of turns to get it screwed down and still move, but we're not wanting to lock it all the way down just yet. Will come in a little bit. When we go to get everything lined up and square. Once again, Miss Dragon, welcome. Okay, repeat the steps at the other end of the same 2040 using another one. So we're going to do the other end over here. And I'm doing both of these at the same time. The washer, holes, backing plate, locking clip. And onto our 4 peanut. Make sure you put your T-nut in the right spot, meaning it's got to be at the top of the extrusion. So top of the extrusion, right, left, top of the extrusion, right and left. Screws. So on the shorter ones, shorter 2 extrusions, we're just going to load in the T-nuts at the top edge, because these will go between these two. So load in our T-nuts on the edge here. With the other 373 millimeter extrusion. Yeah, now it's talking about putting the extrusion down with this piece at the bottom. I know that probably didn't make a lot of sense. It wants us to put it down like this, match these up so everything's nice and flat as I'm trying to lock in the other side here, but I won't be able to verify square with it like that. But we'll see what we can do. So let me see what's the one printed piece. Not want to stay in there. So what I'm going to do is go long ways here, short ways like this. And that will let me bring it right up to the edge of my metal because there's a little bit of a lip here. I'll line up the hole just shy. And get my M4x8 started into the um, lock nut. To get it started into the lock nut. Oh, then I'll bring these nice tight into the corner here and tighten this corner up. Now the other thing I can do is take a 1, 2, 3 block and set it right on top and use that to make sure I get a nice good corner. I make sure I can get into the darn screw head first. Use my 1, 2, 3 block to make sure I'm getting a nice good crisp corner. I tighten that down. Might take some finagling. Okay. Rotate this 90 degrees and do the same thing over on this side. And we'll line this up with our hole and get our M4x8 started, and then we'll get it everything lined up at the. So we've got those two. Now we're going to take and flip it around. Do our last two. Let's do some finagling to get your peanuts to line up. And we'll pull everything nice and tight into the corner. These are 1, 2, 3 blocks as we can to make sure that everything stays aligned. We will be going through and double checking the square on this just like we did the frame. So that's no big deal. We will do that. Gonna keep turning this around just to make sure that everything's nice and tight and flush. Hey, thanks for the follow, Airbrush Master. I appreciate it. The things are nice and tight and square as far as I can get them right now. What we're going to do is validate our square by doing measurements corner to corner. You can go inside corner or outside corner, doesn't matter. And I know we're not going to be square because there's a gap right there. So I had a loose screw. So let's solve that. That, for whatever reason, screw is tight, but there seems to be a little give in this corner. Now we're going to go ahead and measure diagonals. So corner to corner, I'm going to start at 20 on the inside corner here. A 595 F, 20 to 595 and a half, or 590 and a half. Now we do the same thing over on this side. Set this first corner at 20. Set this corner, and it should be 590 and a half, and we're about 592. So we are out of square. We're longer this way than this way. So we are out of square. Check again. Start at 20. $591. 592. It's worth taking our time right now to make sure that everything is nice and square. Better square we can keep this printer, the better prints we'll get off of it. Here we go. We are square. We are square. So we did check for square. We did get everything in there. We did, well, I'm using a 1-2-3 block versus a carpenter square. Hey, what's up what's up, Daddy Wazzy? Doing well. Install two M4x6 roll-in nuts in the rear of the longer extrusions. Two back here. This is going to be to place in some supports. Two back here. Holes facing the inside. Assuming we'll do two on the other side. Repeat this for the other one. Build a couple of more of our angle brackets. You're just drinking coffee? Yep, that's the day. Drinking coffee, building printers. Drinking coffee and building printers. Sorry about that. Respond to something fairly quickly there. As I mentioned before, my little locking clips are slightly undersized. I don't know why. They still work, um, but they're not lining up well enough that these pieces will go through and lock in with them until I start putting screws into. We'll get these prepped this way. Some of these the swarf pops off of real easy. Some of it doesn't, and I say it's swarf, but it's the like stringing. Tiny prints, carbon fiber, polycarbonate. Um, get some stringing between these tiny parts due to the um, whatchamacallit, the retract. Austin Villa and Luton Town on another. Oh, there you go. Yeah, I need to watch um, the first part of Dune. Trying to watch it yesterday and it would not come up for me for whatever reason. It was annoying as all get out. Um, but I want to watch the first um, Dune movie before I watch the second half, which is now out in theaters. And we are putting these in semi loose because we will move them as needed once we get our braces put in. I asked Daddy Razzie, did you play soccer growing up? Yeah. I was gonna say it seemed like you did because of how into soccer you are. And I played as well growing up in the boys club and down in Florida. I mean, it was almost like a penal league because I had one year I had three shirts ripped off of me in games, and I'm talking we were like 8, 9 year olds, not like you know big kids or anything like that. They were just kind of rough down there. Got to wear my shin guards one day, and I have shin splints after taking a sliding kick to the shins. Okay, so we've got our four brackets in there. Now we'll take our 2020s and we need to put M4 nuts on each end. One more of those. And now we're going to set these in and set some M8 or M3 by 8 screws with washers into them. Get them in place, and then once we get them started, then we will find their final resting. It'll kind of be a pain in the butt. Just like before, we're just trying to get these loosely attached. Once we get them loosely attached, then we'll be able to put them in proper place with our um, spacers. Trying to get my M3x8 lined up and in the hole and through the hole, and then I'll be able to get my eyeball my screws a little bit easier. My M3 nuts a little. Okay, these are loosely done. Now, got both sides done loosely. These are going to be the supports for the heated bed. Printed bed frame alignment jigs. Set these 2020 extrusions to the proper locations. Install the 2 printed frame alignment jigs. Now, don't have jigs that look like that. Either I miss printing jigs out, um, or I've got different jigs. Looks like it goes on the 2060. These are obviously a different style, but supposed to be 56 millimeters. That is 56. There's a part of me that wished this was 56, but it is not and not. So keep doing it this way. Okay. So 56 millimeters between the rails. Printed jigs would probably be a lot better and easier to use. And of course, just did that. One side is 58, 58, 56. Other side, 63.5. Hey, Westry, how's it going? We're doing good. We're sitting here trying to line up our rails. So we needed one measurement on this side, a different measurement on this side. We got that part done. Now we'll be on to our belt tensioners. We'll take this, set it over here on our frame for the time being. These up. trying to stay as organized as possible because there's just so many different bits and bobs on this build. Your Z-axis belts are not pre-cut. Cut 2 lengths of 9mm GT2 to at least 868 millimeters. Belts used in the guide are exactly 868 with 434 usable teeth. Not recommended to cut the belt shorter as this will make tensioning difficult. Too long, then proper tensioning may not be achievable. The problematic belt will need to be shortened by a tooth or more. It is better to have the belt too long and insert heat sets into the belt tensioner right cover. That looks like this piece will be its matching piece. And I'm sorry, this tool we still have on there. Yep. Hey, Airbrush Master. How's it going, Westery? And welcome back in, Silverback. Yeah, and it's especially important to stay organized when you've got so many different, like, this is all the different types of screws, and there's more screws over here. There's 7 different types of set screws and grub screws. And those are just the ones specified that don't come with a pulley or something else. I mean, it's crazy. Stay as organized as possible. These go right in the middle of these. They need to be nice and flush with the part. So Westry, do you have any more news or any new news? Did the governor change his mind and recant? So we got our printed belt tensioners cut. We also need to cut our belt if we don't already have pre-cut belt, which would be, give me 1 second, motion that there was belt in here. Looking for 9mm GT2. I think all the belt in this kit is 9mm. And we need 860 millimeters. Grab our ruler here. Yes, 9 mil. We need 868 millimeters. Eight, this right. There's 868. Do one more. There's two at 868 millimeters. Take the rest of this belt and loop it back up. Put it away for now. Yeah, I knew that you said everybody was backpedaling on the support, but I didn't know if they had changed again because, they changed their minds like people fart. Somebody farts, they change their mind again. So I figured somebody was probably going to bitch about not being able to either fly in uh, for the horse races or something that might have another impact on you guys. So I hope not. I hope there's no issues. The belts are cut. We've got this those two parts pre-done with M4 nuts, so or inserts, so we're up to speed. And we did the right and the left because that's the way I am. Oh, then we need to install more heat set inserts. Awesome. And how are we installing these? These are on the insides, and they're going to go down in these holes right here inside. So it even says you'll need to hold the soldering iron at an angle to install the heat set inserts in this area to prevent the soldering iron from melting the sides of the printed part. It's helpful to have an M4 by 40 socket head screw inserted through the bottom so you can pull it down in there as you're heating it up. Okay, I'm just going to take the longest M440 that I have. That'll give me plenty of room. M4 heat sets again. They're saying like try and get these on a bolt. Easier said than done. And these are literally, I mean, they are literally right in the corner. Yeah, you're not getting your iron in there nicely. Um, yeah, we're gonna pop this out. 'Cause I still want to use the M4 tip because it will give me the best, I'll say, heat soak rather than a pointed tip on my other. Um, so I'm going to hold it by here and put a little bit of pressure on it. I'm going to have to come in here at an angle with my iron and try and heat things up. And between pushing and pulling, we were able to get that in there. Try and get the other side going. And I'm trying to get my tip in there as best as I can at an angle to get as much heat in there as I can, but I got to be careful that I don't melt the side of the part. You recall unpatriotic for stopping the military guy? Well, if they could lay out a no kidding military requirement, I think that would be different. And if it was something like World War II, it'd be something different. But this is just basically a land grab. They can't come in and say we need it for this plant because we need to, you know, tool up for the war or whatever. No, they're wanting to move people, and like I said, we you've got the information to show that there's going to be more commercial traffic than military traffic. Okay, so those were put in. Now, I guess before I go too much further, I should sure. After one insert is pressed in, use the attached M4 by 30 to properly align tools. Repeat. Now we need to go ahead and tap a few holes again. Get this down and out of the way so I don't burn myself. Once again, we know ourselves, right? So we need our tappy tap tap. And this is Harbor Freight, aka Princess Auto. Grab our M3 tap and in here. And as we discovered before, it is wise, find my drill bits, to go ahead and run a 2.5 millimeter drill bit through these holes before going with the M3's tap. It'll go a little bit smoother. And these grub screws are going to go all the way through. Be careful when you're doing this that you don't go too far. Because basically you're breaking through here and then you'll foul the threads that are on the other side of the print. So you got to be careful of that. There's one side. Let me do the other while we're at it. Now that we got those, we'll take our M3 tap and tap these holes. We need to tap all the way through, or at least as far as our threads on our tap will let us go. And if you start to feel resistance, then back it off several turns, and that'll move the swarf from the threading process further up in the threads and allow you to then go back and thread a little bit deeper. Once again, make sure that you don't go all the way through the part and start damaging um, the grooves where your belt's going to. One down, one to go. Airbrush Master, I am making a BlackBox. So this is a BlackBox Tool Changer. KB3D has been providing subkits for this printer for some time now, few years. In fact, KB3D started with this, supporting this printer and parts for this printer. So now what has happened is he has worked with the designer of the printer, and he is now providing 100% BOM kits for these printers. And that's what we are building right here is a 100% BOM kit from batch one of the printers. This is a mostly sponsored build. So KB3D did provide the main kit for me, and I have purchased all the parts for the tool heads that I will be installing. So he basically got me everything to build the printer with the X gantry and the cradles, and then I am building the actual tool heads that will be installed in the printer. Purchase the parts to build them. Yeah. So give me a second and I will provide links. I thought they were auto-populating, but I haven't seen them. I was trying to set up my timer in Stream Element to post the link based on the title so I could just leave it active without having to cancel it when I'm not doing my black box. Give me a second and I will make sure that you get that link. once again, normally you don't want to thread your plastic parts, but the pieces that we are threading are for grub screws. Okay, so not a whole lot of tension on there when we get these done, but it will be enough to hold these parts in place. Once again, we just ran threads all the way through here. We're going to lay our belt in here and we'll run our threads, and that's what's going to hold our belt in there and keep the belt from coming out when we use the M3 uh, grub screws. So we've done all 4 screws, or all 4 holes, 2 on each side. Oh, which, ah, I just put my taps away, and we got to do the same thing on these sides right here. So grab the tap again. Always read ahead before you put away your tools. Hold on. Let me see if I can kickstream elements into throwing that link up. Oh, it looks like it looks like it's set without any stream title pieces. Should hopefully see the link here. If not, pop up recently. There it is. Let's go ahead and throw it in here. So this is the link where you can go and check out the configurator page by KB3D Chris. And if you really want to know more about the black box as a whole and kind of the mantra about it, this is the kind of the black box wiki page, is the blackbox3d.xyz. And each page will have like a guide and a 3-dimensional uh, like a web-based 3-dimensional CAD view that you can zoom in and turn around just as if you were in Fusion. Or you can go right into Fusion if you really are a glutton for punishment. Then we're just going to pre-drill these holes and make sure that they're at least 2.5, so it makes tapping quick and easy. You can see as I go in here, we want to be careful that we don't go, well, we want to be careful and make sure we're going straight. Now you can see the tip of my drill coming there. And we don't want to go too much further because once again, this side of this part has the grooves that'll match the belt. So if we go too far in, we will damage those grooves and things will be no bueno then. Or at least will be a little bit harder to slip our belts in. And once again, we're cutting into plastic, so there's no need for cutting fluids or anything on this right now. We're just doing our threads into the plastic. All to make it easier to thread in our grub screws later. What I'm doing there is I'm just blowing out some of the plastic that's getting pushed into the channel ahead of the tap, just so I can make sure that I'm getting the tap as far in as I can. Because once again, the first part of this is a chamfered edge, and you're really not tapping any threads in this chamfered edge area, tapping threads back here. So we're trying to get as far in there as possible with the tap. This is the one I just did. So far, this has been a really, really good kit. It's had everything in there we needed. We had an issue with the slot 8, aka the 4040 M4 T-nuts. And the issue there was not with KB3D, it was that the T-nuts he got were all supposed to be M4. He doesn't stock any M5 4040 T-nuts, but unfortunately, about 25 of the T-nuts that I got were M5 threaded. So that wound up being a supplier issue, not a KB3D issue. So he said right now about half of the stock that he has is M5. So I'm sure he's going to go back to his supplier and work on restitution there. Okay, so we've got those two done. And we're going into inserting the belts. So hopefully that means we're done with tapping for the time being. Move this stuff back over here. And we're going to start with, looks like the right side. And we're going to put one of our belts in. And once again, this is where it's critical to keep those screws in there intact. Those belt goes in nice and easy. And I will say that so far these belts and these prints have gone in very easy, especially compared to my prints on a Prusa. Every time I try and slot belts into a print for a Prusa, it's god awful. These have been really nice. So we've got the belt put in and all the way down into the printed part. Now it wants me to use my M3 by 6 threaded insert or M3 by 6 set screws. To set in there and hold these in place. Now, on previous pages in section 2, it was telling me to use Loctite on these. Do not use Loctite on your um, printed part. Okay, I've taken some notes. We're going to send some notes over and have those pages updated. Do not use Loctite when you're going into your printed part. These are the parts that I'm using are polycarbonate, so they probably wouldn't be all that bad and be um, compromised, but don't take any chances. And if you're doing ABS prints or ASA prints, definitely do not use Loctite. It will make your prints burn. And these will take a while to thread in just because one, they're a tiny pitch, and two, um, we're going in there decent. Like pretty close. All the belt deformed finally. We take these snug up against the GT2 belt. Once again, we just want to make sure that the belt's not going to come out of its own accord. Now you've got it in there held in with like 1, 2, 9 threads, but just to be on the safe side, this is holding up the weight of the entire bed, and you've got the weight of the bed and the frame. So I don't know if you guys can tell on this, but you can see where the belt's kind of deformed a little bit. Tells me the grub screws are hitting the belt. That's what we're looking for. Going to make that very, very tight belt clamping. Now we're going to do this with the other part. Make sure to line up the belt in the right way or the same way. Get all your teeth lined up in the grooves. You can use your fingernail. I would suggest doing it only if you've got like short fingernails, or take a flathead screwdriver and use that to push the belt in fully. Promise your belt's not going to get mad at you for pressing on. All right, so that's fully seated in there. Now we're going to go ahead and put in our grub screws, so another couple of grub screws, and run them for days. Um, I don't know if this is where Prusa got the idea for the XL, because I think the E3D Tool Changer and the Jubilee um, were out before this was. Probably be where a electric screwdriver would come in handy, or at least until it could get it down there until the bit uh, ran out. Yeah, the E3D tool changer's been out for several years and it's now been discontinued. I think they're just focusing on their hot end line rather than the tool changing. Okay, so those are set. Put the bed down. Holy crud. These way, these way. These will put in. Take these two parts and set them over on the side for the moment. And let me check and see what it says to do with the bed. I'm going to mount the heater on a thermal fuse. Okay. So this is going to be another case. And so this note on page 30. So section 3, page 30. Move before heater. And okay, so whenever you're doing a bed, you want to do your magnet first. Okay, because here's why: you're going to do your magnet first. Then you'll be able to use your holes in an M3 drill to drill pilot holes to know where you're going to cut your areas out for your mounting bolts. Okay, and you want to do that because that's a flat surface. You have to press down to get that magnet nice, good, and attached. Then you're going to flip that over, and the magnet's going to be facing down. And when you apply pressure to mount your heater, you're applying a second round of pressure on that magnet as well. So you're making sure that it's really good and stuck on there. The other reason is when you do um your heater, there is a thermistor in there, and that thermistor is a glass bead, right? So as soon as you put that on and then you flip it over to do your other surface, you stand the chance of crushing that glass bead and breaking your thermistor. So you always, my preference is always do the magnet first, then flip it over and do the heater. Now, with that being said, I've got a dilemma here because I don't have the magnetic sheet yet. Okay, unless I've got a spare one around here, I don't have the magnetic sheet because KB3D is out of the 300 size magnetic sheets and surfaces. So let me check and see if I've got a 300 magnet. Ooh, 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 uh-oh. And I do. I have a spare 300 magnet and I can tell it's got the rounded edges. It's pretty thick and it's got the 3M on it. It's also dusty because it's been sitting there for a while. But this would be a good one to use. I've got another one that's cut square and it's not actually, let me rephrase that. It's got non-rounded square corners and it is not fully squared. I thought I went, I'll double check. I thought I went with the standard bed, but now I'm gonna get into the other box over here and dig it out. So give me a second. Because it's under a bunch of things. It's this side. I thought I went with standard bed, but I'll double check. I may have said standard and you still sent me the mag bed, but that's okay. We'll see. If I've got the mag bed, that's even better because then I don't need a magnet anyhow. But regardless, Chris, this note and I took a note on it. You want to install your magnet first before the heater, so there's less chance of cracking the thermistor after the fact. You could be crazy. Yeah, you could be. But either way, they're back in stock as of Friday. So flex plate is inbound. Okay, cool. And you are crazy because this is a, oh no, this, you did send me a mag bed. Well, hell, I don't need this at all. I still got a spare magnet then. Well, ha ha ha. So this side is up then, right? This is the side that the build plate goes on, not this side. Just double checking because, like I said, I've never used one of the Mandala Roseworks beds, or not the mag beds. Doing place the Mandala Roseworks face down on your clean work surface and orientate it as shown. So the yeah, this has the recessed holes, so this would be the top. So this would be for the 2.4 mounting pattern, which would be like this, but then I don't have the other holes. What am I missing here, Chris? So let me go full screen real fast. And dang it, I want to try and get this full thing on the display. So looking at our hole pattern, you have 4 holes on the side. Well, here's your 4 outer holes, and then here's the 2, and then here's the 3. So this plate and this diagram do not align, by the way. I mean, it's a square. It's no big deal. Um, well, sort of not a big deal. We still need to make sure that these line up with the cutouts. You use the trident mounting holes. Okay, but what I'm saying is it says to orient it with the 4 holes like this so that it lines up with the magnet, and then you would have your other holes here. So if I line this up with the, all right, yeah, we'll just have to line it up like that. Make sure I've got the 3 down here where my mount plate comes out of. It's just a difference in the way that the hole pattern is drilled versus what it's shown in the diagram that can, yeah, you can't see me, but let's go back to this view. So yeah, I would have to mount like this because if you try and line it up this way, it doesn't work with any of the holes. Once you lay it on there, it's just we may want to update the diagram to show this the right hole pattern, because this is normal. Like this is a standard layout for a trident anyhow. So all trident beds, dual purpose beds would look like this. I mean, this works because here's the two sets that would mount for the 2.4, and then these holes and the center hole would be for the trident. This works. I'm just saying the diagram will throw somebody off when they're looking at the build plate. Kind of like it was throwing me off looking at the build plate. Regardless, we got it lined up. We got it lined up. And like I said, I would make the note about doing the magnet first if you're getting the magnet versus the magnetic or the mag bed, because that way there's no chance of crushing the there's no chance of crushing things. But your wires need to head out the back. So I want the center hole mount for the trident to be away from the wires. Is that what I'm hearing you say, Chris? Okay, because yes, okay, this is, again, most people do not install these with all the wires going away from them. They install it this way because this is the part that you normally start with. So you're killing me. You're killing me. So we'll start and we'll go ahead. Yeah, you're killing me, Smalls. Go ahead and peel off the little bit of the front edge here. There you go, Chris. We'll just say it's Poity's fault. Yes, I am used to Vorons. You're right. I'm just trying to get this lined up here in the back. Walk my way forward. Go lined up there. I'm going to start tacking the front edge down. So once again, I hope we're right. I'm going to tack this front edge down. Reach in here and grab the paper without touching the plate, preferably. Feel a little bit more. Once again, pay attention to your thermistor. Do not put direct pressure over the top of that thermistor. Go around it, yes, but do not put direct pressure on that thermistor, because if you bust your thermistor, you're going to be doing a new plate, or at least tearing this one up to get to the thermistor. And you'll see Steve, when he does his, he'll break out like his tile roller or something. I don't have one of those. Well, like I said, once you start sticking this down, if you wind up running your wires the wrong way, you'll be doing some custom wiring. Okay. So that's on there. And locate the thermal fuse. Yeah, thermal fuse. Back in the big box. Pretty sure. Was that, I'm trying to think, was that loose? Could have been. Take a look in the electronics. Here it is. In the electronics box. Makes sense because, well, it's an electronics item. For the time being. Yeah, it was in the electronics box. Let's flip this around and make it look like so the wires are coming out of the top for no apparent reason. We'll put our thermal fuse. We'll go right here in the M5, right? 5x10 button head cap screw. Um, I do not see any M5x10s. So I yeah, no M5x10s in here, Chris. Um, yeah, that'd be a top tray item. These are washers. These are actually the M3 nylon locking nuts in all of my M5 T-nuts. These are all M3 button head cap screws, and 4x8 and 4x30 set screws, M8 by 25, 2020. Yeah, there's no M5 by 10s in the kit at all. But don't you worry. I may have. Oh look, I I, I can spot you one because there's a few of us that build Vorons that have a few. You know, I find my lack of a beanie disturbing as well. Um, I don't have a hat and I don't have a beanie because, um, yeah, my design, my current channel design, um, does not work well with those because they're not silk screen. Yeah, first get funsies. Those parts are hats and beanies are not silk screen, they are embroidered. And with the logo that I have, it's not gonna embroider well. Now, be mindful. You saw I did put some Loctite on this. This is a ceramic fuse. What else do you know that is ceramic or porcelain? Your toilet. What happens when you over tighten screws? It cracks. Do not over tighten your screw and destroy your secondary thermistor or thermal fuse. Excuse me, thermal fuse. Yeah, I need to get a beanie of some sort. I agree. Okay, locate the installation instructions inside the Mandala Roseworks Matched Height Kinematics Kit. After a cursory read through, use the image below to identify the holes in the bed that will be populated with the kinematic ball fastener. Awesome. Oh, so the kinematic kit, one of two boxes. That box, thought it was. Yep. So when unpacking the box, do not let the magnets snap together. Keep them separated. If they snap together suddenly, they will shatter. Well, that's good to know. Oh, hey, instructions. Mac mount type mounting kit. This is a pretty neat little kit. Very nicely machined. You know what, Pez Coffee and lube shirt. Kind of has a ring to it. Kind of like Apocalypse Now. I love the smell of coffee and lube in the morning. Okay, alrighty. So we've got a 15 millimeter base, a 12 millimeter base, and another base. So 15, 12, and then the other. So it looks like oh no, there will be no drilling. No drilling here today. This is just saying put them here and here. Yeah, yeah, that means I actually have to like pay attention. Okay. Just worry about the ball studs for now. Oh look, we even got slide in T-nuts. Ooh, springy loaded slide in T-nuts. Look at those. Them's a snazzy. standard T-nut because somebody wants to be a masochist. Okay, so what do we got? We've got all button head screws. All button head screws. I'm going to assume slightly larger because there's only two of those. These would be our long ones that will go into the ball downs. Three of those. These would be the two smaller ones probably that go in the there. Okay, so the big screw goes down in the hole. Yeah, because these will go into the hole and become the mounting point on the rail. Supposedly, if I can get it lined up, yeah. That becomes the mounting point on the rail. The ball joints go into these, go into these, go into, I'm assuming, the magnetic rings. I'm just trying to get everything kind of laid out and put together here so I can see what the hell I'm working with. All of our balls are the same. We get one of these down through the ball screw. This gets mounted on the back plate. Okay, so this, no wait. This goes through the plate, ball screw goes on, and then it sits in these, which are the mounts. Okay. See, it just took a bit. It just took a bit. So the ball screws mount in these trident mounting points, and then everything else here goes onto the frame. And you say I was starting to have a moment? Okay. So these are going to come in here, and then our balls are going to go on the other side. Do we put Loctite on these or not? I don't think we'll need to. really bad? Now watch the wires. You come over to do this other side. Don't drop your ball. Okay. So now we've got our 3 ball mount points on there. And we will set this aside. We're going to bring our frame up. And I'm assuming we're going to be going on the top here. Oh, yeah, you did. Now, Chris, one, so I didn't have these printed parts. I don't know why I didn't print them out. So I did just measure them, but the one side was like 56 and the other side was like 68 and change, 68 and a half or six, something like that. So when it starts talking about putting the 20 series, I got to figure out which side that is. So I can look at the heated bed. The crossbar extrusion. Yeah, so I'm looking over at the bed mounting diagram, trying to figure out what. Okay, I got it now. I got it. There's like another extrusion that needs to go in between these two. Okay, so one here, probably one over on this side then. So doing it here, this is going to be the front. I guess because it's offset, smaller gap to the right as it's sitting down right now, correct? Because this would be I'm assuming that this is the top, smaller one over here, larger one on this side. Yeah, and some of these just feel like they bottomed out before they tightened up. Maybe I just need to break down and get my L-shaped Allen wrenches to tighten those. Um, yeah, the bed frame's upside down or will be, but this is the 56 gap, and this is the oh wait, this is the 50. This is the longer gap, the 63 and a half. This is the 50. This is the 63. So, all right. Yeah. So it needs to be upside down. I was just trying to figure out and make sure. So the shorter gap is on this side, the longer gap is on my left, shorter gap on my right as we do this. Um, which means the cross members coming on this side closest to. That's what I was trying to figure out is which side that cross member will be aligned to. Well, and it's just looking at the even looking at the picture, right? It doesn't tell you which side the offsets. So when you're doing this, if you had just a marker or just numbers here that said 56 and 68.5, whatever the hell the numbers were, that would help because we would immediately know the larger gap size is over here. So we knew that we would be putting it in on the right end. Pull towards you, by the way. Placement doesn't really matter just yet. You do the other two corner brackets that we had left. Like I'm kind of curious, like why didn't we go ahead and do this when we did the frame to start with? Why was this held off until we started putting the bed together? Okay, hold on a second. I think I'm about to die on my battery, so let me plug in before that happens. So I have been using these fiddly things that I printed out, these little L's and the pieces that go in the middle. And I don't know about you, but mine are not locking in. I don't know if it's I mean, that goes right there, but the parts aren't locking in when you put the center rings in. So I don't know if I saw that you sent something on Discord. I didn't know if they were different than these. I didn't look too hard into it. But these are definitely a little fiddly. And like I said, I've yet to get them to lock in. So the best thing I do is get them close, and then I'll put the M4 by 8 and washer in. Once you get the one side down, the other side will stay lined up. Oh, God, yes. Blind joint would make life a lot easier. Blind joints would make life a lot easier. And these parts are so fiddly to print because they're so small. They do tend to um, whatchamacallit, string. Hey, it's a cool little system, don't get me wrong, but it's kind of a pain in the butt. DLL PDF is working on the blind joint bed frames. Nice. Now, DLL PDF also does the different colored frames. So, are you possibly going to provide the option for different colored frames for Blackbox? Because I hear that some undead mammal wants a different colored frame than Blackbox, or I should say, than black for Blackbox, which I think is somewhat blasphemous. So that's that. You're not sure you should enable that behavior? Exactly. Locate the remaining 270 millimeter extrusion. So our last extrusion, going to sit down in there. We're going to need another couple 4040 T-nuts. 4040. Wow. We're going to need another couple of 2020 M4 T-nuts. Ooh. An indication of not enough coffee, apparently. Or at least that's the story that I'm going to stick. Um, Use two printed standard bed frame alignment jigs to locate the extrusion corner brackets within the bed frame as shown below. You know, like I said, I was pretty sure that I printed all of the parts for the first three sections. Got rail guides, but I don't have. All right, well, what the hell? Because these are the only other things that I have, and these aren't, definitely aren't those. Um, so 31.5, is that the gap between them? Currently blind. There we go. All right, and our measurement's 31 and a half. Inside to inside, assuming. Okay. And if I am off like half a millimeter, I think we'll be okay because of the ball joint. If not, then I will be doing some things off stream to make sure that everything is lined up. Yeah, that's the thing is I'm pretty sure they were in there and I thought I had printed everything out. Maybe I didn't. Hell, let me check real fast. So on Fiber, I may have just missed a plate. All the instructions included the match height kinematic system to assemble the mounted assemblies. Position on the bed frame is set by the following printed jigs. Now, assuming that those are not these, so as these are 2040. Okay, and are we still leaving it like this? So the bed's kind of mounted down within the frame rather than on top of it? Okay, sounds good. Each keen. So this side is 68.5 and it's this spacer. So just looking at the way this sits. So this will be the underside, be the side. Okay, so we're gonna need, where are these fours? So some M4 nuts, 2020s. Yep, I sure did. I missed an entire bed of prints, which is everything that we've been working on here. That is fantastic. And it's only like, I don't know, five 5 hours to print it. So maybe I can run through and revalidate everything afterwards with the jigs. But we're gonna take our M4s. This one is over here. We're gonna need a 1, 2, 3 block to keep this. Let's say I need a 1, 2, 3 block to keep this square. Not gonna keep it square either. Thought process, Luke. I'm gonna need a square. Left side, 65.5. Okay, there's that side. The right side, which is what am I missing here? I have a 12 millimeter and a 15 millimeter. Which one goes where? Okay, so chamfered mag mount goes opposite of this one. Chamfered mag mount is the 15 millimeter, so it's the thicker one. Gonna go over here. This one has the blocks in it, keeping it straight. easier. Now those should auto square themselves nicely. And I can't use the roll-in nuts. I can't use our standard roll-in nuts. I think I have to use theirs because this hole is off-centered and it won't fit in the machined mount, which is centered. I'll have to use their machined roll-in nuts. I could probably use for all of them. Use like that. Okay. And the right is 63.8. Well, that's not going to happen with the ruler. 63.8. Okay, that one's nicely done. And we'll build the top on them here in a second. Because I'm glutton for punishment. The way these work is you take the lips, these little tangs, put the tang in, push this side down, and then push it, spring it down and roll it over, and it'll line up. Got that one. Left side was 65.5. Okay, and then the last one will be over here. This will measure 122.3 coming from this side. One 122.3. Did I scream at myself already? Because when you put these little pieces on, they actually be it. They actually become the locking pins. Okay? Put them in the right place. They also work better that way. Well, Chris, it all makes perfect sense when you look at the mandala roseworks thing and then you start really looking at it and then thinking about it and you go, well, that makes sense. It's got to go in this way or that way. They go in this way, so that will auto square it. Now we just have our distance set. Okay, now I can start building the tops. So this one has the two magnets, not two magnets, but the two balls going like this. These. Now, Chris, the mandala rosework stuff is not calling out for Loctite. Would you put Loctite on here or did you put Loctite on yours? You didn't and haven't had an issue, but surely you could. Yeah, that's what I was thinking is I didn't think I would have an issue because it is a kinematic mount. Um, cover up the instructions that you still need to look at. Because the ball is going to sit right there, and then the ball will sit in these various chamfered areas. So 12 millimeter was back here. 12 millimeter gets the rounded base. Well, the good news is I'm taking it apart anyhow because I forgot to put the magnet in it. Oh, so we have opportunity number two to put some Loctite on it. Oh, don't Loctite the top screws? Sounds perfect to me. Wait, Jesus. Do not let the magnets slap together. Also, you're going to kill yourself trying to get the magnets apart. Good gracious. Oh, and it doesn't show like putting a space or anything, so the magnet just sits straight down in there like that. Top piece will go on. Oof. Okay. And then the 12 millimeter was over here, so it gets the other flat magnet with one of these chamfered lids with 4 button head screws. Okay. And then this one gets the chamfered magnet. Last plate, 4 and 4 screws. Well, I haven't used this. I got the Trident 350 from DFH has the Mandala Roseworks or yeah, no, Whopping Packard's kinematic mount system, which is a little bit different than this, and it's pretty good. It's got the little leaf springs. I'm curious to see how this goes, and maybe I get one of these for Iron Dragon, which is the Giant 300. Okay. With all the fasteners secure and heated bed, no, with all the fasteners secure, the heated bed can gently be lowered onto the kinematic coupling. Once heated, the bed should be resistant to light force applied in any direction. Okay. Now we haven't done any wiring down here, so I will say I'm hoping that we would be able to still play with that stuff. That out of the way. Not sure what that T-nut was for. I'll say the whole bed mount's moving without the bed moving. Then you've got a chamfered, cylindrical chamfered here. This is on 2 ball bearings or 2 rollers over here. And then this one is just straight on the magnet. So it's got nothing to constrain this side. So it can fully move around within the scope of that magnet. So it just lifts off later. Yeah, okay, great. That'll be good because that makes taking things on and off for maintenance and mounting easier. Because I'd prefer not to have the bed mounted because it's just added weight right now. Okay. That away. These can go in here. Okay. Turn it to the right. So we turn to the right. Right side's facing me. We need to put 4 M4 T-nuts, which would be 3 of the ones I just threw back over here, plus another. Place the printed Z-belt tensioner part 3 onto the extrusion so the holes in the printed part line up to the holes in the M4 slot. May have moved one or more. Yeah. And these are that's this print, right? Yes. I'm going to slide this off the bed. Yeah, only one side has this part. That's why I was like, there, I'm not seeing more than one. And that is a really thin, floppy. So just be careful. Okay, so we're just going to use this to line them up, and then we'll use, yeah, there'll be something else that'll go on top of it. So those are lined up. We're going to grab right belt tensioner. And to remember which one's right and left, we'll say the right belt tensioner. If we're looking at this diagram, it shows the M4 heat sets offset to the right some. That's the one we're looking at. This is going to line up and match up. M4 by 35 flat head screws. Just getting all four of these started before I screw them down. Crossing pattern, of course. Oh, wait. Very specific. Loosely, yeah. Don't screw them down yet. You want them somewhat loose so it can move. Yes. And this is where we're going to use these parts, assuming. Why? No, okay. Place the tensioner tool at the right front corner of the bed. To show, move the right axis belt tensioner assembly so it is flush. Okay, I'm just trying to figure out. So I've got two different ones of these, Chris. One's a little bit longer than the other. Ooh, that makes sense. This has the long, um, this goes all the way, and this one has the front cutouts, the space, and then the sides. So this is one we're using. Yay! See, it's all about just looking. Just gotta look. It's intuitive. Move the print installation tool. Place four, or place an M4x6 socket head cap screw, the M4 washer loosely install into the right face. Okay, so we're just putting these into the heat set inserts. So M4x6 socket head. Now we're going to do the same thing ish on the other side. And to do it on the other side, this does drop down a little bit. So let me grab a couple of boxes. And once again, we're going to pick this up, spin it around. We'll need 4 of our M4s over here. We'll use the other one to line these up. We're going to use some M4 by 25 flathead screws. Yep. Yep. Now we're going to place the D-Welt tensioner installation tool at the front corner bed frame. So same tool we used before, front corner again. Make sure everything's nice and tight. Bring this all the way forward. That one's now installed. So while we're on the left side of the bed here, we're now going to install some more of our M3. Not more of, we're going to install some M3 rolling T-nuts. All the holes are facing the side extrusions. printed Z brackets. So these only go on one way and line up. So the top will be here, and then we have the longer drop bottom to it. That's the part that's going to be facing down. And these are going to get put on with M3x14 socket head screws. Hey, Pez. Yeah, well, I think we're getting close to being done here. And as soon as we're done with this section, I'm going to, I think, order some pizza and try and chillax. This is the axis. Keep this process for the rear. Once again, we're just getting them started. We're not fully tightening them down. Partly because we want to make sure we can get them all started. Okay. Mount the bed frame. Set the assembled bed frame aside. Place 4 printed bed frame alignment blocks on the 2060. Well, hallelujah. I at least have these. M3s, the M4 washers will go in here. Not there for now. We're going to take this and set it down on the ground. Boy, light came off. Get our Polymax polycarbonate out of the way. We're going to bring this up. And we are oriented as we see in the picture, which is the front here, or the front, the back here with the Z motor. And we're going to take our 4 blocks, and we've got the 3 grooves back here. Those are going to line up on the 2060. Now we're going to place the assembled bed frame on top of the printed bed frame alignment blocks. It'll be stable and flush on the printed alignment blocks on each corner. Your bed frame is skewed so that one corner has some space between the alignment blocks and associated extrusions. Then loosen the socket head cap screw on the outer 2040 bracket and press the frame down so that, so if your frame's not fully square, make it so. And I'm taking the bed off, partly because the bed came off on its own accord. And our belts apparently seem to be facing front and back. This is the way our alignment blocks will go. I say front and back. I think my front and backs are skewed on my in my mind right now. All I'm doing is taking the blocks and moving them to the side so that everything lines up. We're in the 2060s. Everything is sitting relatively flush. We can move this side to side on the blocks, but everything's nice and sturdy. The assembled bed frame will now be attached to the machine. When moving the linear rail cartridges, be certain to not let them slide down too far to avoid damage. Best to keep them secured with loose painter's tape, yada, yada, yada. Start with the Z-axis linear rail secured to the 2020 extrusion, so the one that's facing you all, this one. We're going to need 4 M3 by 50s. We've got our 4 M3 by 50s. Probably going to need these, but I'm going to get these through the edges here, get them ready. Move the tape here, but holding our carriage. Don't want that to fall off. Let it slide down. Now it's a matter of trying to line up our side to side, top to bottom. There we go. And so once again, we will do this in a crossing pattern. And I'm just snugging it up. I'm not tightening them all the way down. I just want to bring it snug. Okay. So this rear is snug. Not causing the bed to tilt or skew during. Keep the assembled bed frame flush to the printed alignment blocks on the corners while you fully tighten the four socket over tightened screws in the MGN12 carriage. Over tightening will cause deformation of the bearing races in MGN12. And I don't think I have these tools. That would go right here to prevent the bed from being torqued too hard onto the, well, we'll line it up with this, with the carriage. This is where I really needed that other bed plate to be printed. We'll go ahead and get that started. I may, it's still nice and good. I may have to leave this here until we can, yeah, I'm gonna have to leave it like this until I can get those other parts because I need the brackets in the front to make sure that I'm not skewing the front piece when I install those. Um, so I'm gonna get that other plate of parts going, and it will also, while I have the bed off, it will allow me to double check all the measurements here. So if any of these side measurements are off, I can get those squared up. But we're going to have to leave it here because I really want these spacer blocks in place when I go to start tightening the sides, get everything done right. So yeah. Okay, so everybody, this is kind of where we're at. I'm going to we have to go ahead and call a stream because it's going to take like 5 hours for that part to print, which means we may have a short combo stream either Monday or Tuesday night. Well, actually, we'll probably do a short stream on Monday night just to finish getting the bed, this bed section done. And then Tuesday we'll be working on the enraged rabbit carrot feeder. So yeah, that's kind of where we're at the moment. I wish I had the other printed parts, but I didn't. I failed to print one of the pieces, so that's bad on me. But we're doing good. Give you an idea here. So bed wise, we're gonna drop down. Whoops. Try that again. We're gonna be coming up in the gap between the printed part and our um, carriage. If I can find the gap. Can't believe this is that much of a pain in the butt. There we go. That belt's going to come up here, go around the pulleys, and then come back down. This is going to give you an idea of how the belts are going to be run. Once again, we'll have a tensioning block that'll come down in here. So that'll give you a little bit of an idea of how the belts are going to run up. So we're doing good here. We've made real good progress, but we're going to have to, like I said, we're going to have to wait until I can get those other printed parts done to, to make sure and get the front spaced right in relation to the back, so that we don't skew the bed when we put it in the frame, because that would be bad if we skew the bed at this point. So thank you once again, everybody, for being here. I appreciate you being here with me today. Like I said, look for maybe a short stream on Monday just to finish the bed stuff up, because it is going to take a number of hours for those to print. And then what else? What else? What else? Um, yeah, I think that's kind of it. We're going to get the bed mounted, do the belts, tension the belts. Yeah, so not too much longer to go. We'll be able to bang this out, I think, on Monday. So, yeah, we'll get this banged out on Monday. So, thank you once again, everybody, for being here. Let me go and figure out a raid target for today. Let's see who's out there raiding, or who's out there streaming right now. We got AZ Pinoy, Sid Heresy, doing some electronic stuff. Vile Mods working on a shock stock. Mayhem's doing some printing. Stephen Poole, Maker Deck. Free Heathens on. Ugly Moo is on, playing Paul World. And the Jerry Show's on with somebody bugging on there. It looks like, is that Lightspeed? Um, let's see. How about we all jump over to Free Heathen? Go show Free Heathen some love. He will probably raid out to the Jerry Show himself shortly. But yeah, Thank you, friendos, for being here. Please go with me and share some love over with Free Heathen. And like I said, maybe do a short stream tomorrow night just to finish up the Z-axis. And then Tuesday, it'll be back to the enraged rabbit carrot feeder. So thanks everybody for being here this evening, today, long day. And thanks for hanging out, chatting. And Chris, thanks for being here to help answer some questions along the way as I was starting to get a little bit confused. So we will see you guys tomorrow. Take care now, and bye.